This is the Henrob oxyacetylene welding torch. The demonstration you're about to see is mainly due to requests from a load of our customers who are unable to get to the field days to see the torch operating. However, I would like to stress to you that it's the same demonstrations as you would see at any trade show or field days. Now, the Henrob oxyacetylene torch is totally different than a conventional oxy torch for a number of reasons. Firstly, the torch uses only 4 psi 28 kPa on both the oxy and acetylene. This has the effect of using up to half the gas of a conventional torch, also enabling you to use very small bottles because of its lack of gas usage, so it's a very portable unit. Secondly, the torch delivers the oxygen and acetylene in equal quantities, unlike a conventional oxy torch, which delivers approximately 5 parts of oxy to 2 parts of acetylene. Now, the torch also has a unique mixing chamber and special low velocity tips. It delivers the oxygen and acetylene in equal quantities, and the special low velocity tips delivered in a very narrow concentrated heat pattern. And most importantly, it delivers a non-oxidizing flame. Now, I'm going to get Lynn over shortly, and we're going to start our demonstration by showing you some panel steel, the torch's lack of distortion abilities. We have here a piece of panel steel, and we've just tacked it together at a couple of points, and what we're going to do, or have done, is set it up nice and square, and then fusion weld the panel steel together, just to show you its lack of distortion abilities. Now, you'll notice straight away the very narrow concentrated heat pattern of the torch by looking at the red hot area. With a conventional oxy torch, you would have quite a large spread of the red hot, about ½ an inch either side. Now, what we're demonstrating here is that with a conventional torch, you would have these 2 legs lifting out in either direction and buckling all over the place. The torch really hits very concentrated, similar to what a MIG or a TIG would do, and a lot of this distortion, or most of it, has gone. Very nice. Now, you can see, if you look inside there, the penetration of that weld. But what we're mainly showing you is the torch's lack of distortion. And you can see there that that's barely even moved. Fantastic for panel beaters and car restorers. They love it for its abilities in thin panel steel. One of the advantages of the torch is its ability where you can just hook it straight up to your standard hoses and regulators. We're just, in this demonstration, you'll notice, using standard SIG weld Comet regulators. Now, for the next part of our demonstration, we'll show you much more clearly its narrow concentrated heat pattern. We have here a piece of 1 mil aluminium irrigation pipe. Now, notice that irrigation pipe is quite dirty. It could even be covered in paint or engine oil, makes no difference whatsoever. And what we'll do is simulate repairing a crack in there. We'll hold the torch on the top of that pipe and just blow a hole in it. Now, if you were to do this with a conventional oxy torch, you would just collapse a large part of that. This torch just blows a small hole the size of the flame. And as you can see, you can use the torch to actually controlled melt a slot in the material. Now, we're just using standard aluminium filler rod, 5356 rod, that you can get from any welding outlet. Very important to say that we don't require any specialist rods for this. In fact, a coat hanger, old aluminium coat hanger, works perfectly well. Now, even very expensive TIG gear, even up to $5,000 or $10,000 worth of it, does not like to bridge a gap as wide as that in thin aluminium. But the torch will do it very, very easily. You can see the control of it there. A lot of people who use it say that it's just like soldering, as easy as that. The torch uses only 4 tips, I should say, for its entire welding operation. and those tips cover the range of the torch from fine jewellery up to 1/2 inch mild steel. You can see there quite clearly how beautifully that's done that repair, and if I hold this slightly up, you should be able to look inside the pipe and see the penetration of those welds. Now, we'll drop this in our water, and we'll now demonstrate using some 1.6 mil aluminium, just to show you again the torch's remarkable abilities with thin aluminium. Again, just using standard filler rod. Notice here we have a slight bit of flux on the rod. It's just standard SIG flux that we mix with a little bit of water and put it on the rod, just to break into the oxide layer for aluminium. Now watch the control of the torch into thin aluminium. If you were holding a conventional oxy torch on that 1.6 mil aluminium, it would be a molten mass at your ankles, probably about now. But the torch is very, very controlled, and you can see you hold the torch about 20 degrees off upright and push the filler rod under the flame and out of the way of it again. That is the technique with the torch. Now I'll just cool this off. If you bear with me a moment, and then bring it back up and show you it. Sorry. You can see there that beautiful weld, but also turning it over, most importantly the penetration on the other side, really right the way through. The torch also has unique abilities with stainless steel. It'll weld stainless to TIG strength, and we do have the test results available with that, which are sent to you with the brochure that we send with our video. We just use a standard TIG filler rod, 316L filler rod. There we are. No flux is required for this. If you slightly carburise the flame, now the torch has tremendous abilities with stainless steel, the same as aluminium, particularly at the fact that it's very, very little distortion. Now even very expensive TIG gear tends to distort thin stainless steel. We had one of our customers who is a TIG operator and uses a very expensive TIG do this same demonstration for us with his TIG, and he lifted the other end of this material up nearly 1/4 of an inch in the air, because notice we haven't got that tacked in any way at all. The torch actually uses just standard TIG pickling solution that cleans those welds right up beautifully. It also has no trouble welding stainless steel to mild steel. Dissimilar metals are no problem to it at all. If you keep the filler rod right in the flame, you can get a very, very neat weld there, as you can see. The torch also has dramatic cutting abilities, which I'll demonstrate at the end of the welding section. It'll cut up to 1 inch thick steel as well. And you can see there the torch quite easily welding that stainless, but most importantly with very little distortion. Thank you. We'll keep you on then. I'll put that in the water and bring it back up and show you. And you can see there that quite beautiful flat weld. Cleans up superbly. In fact, I'll show you a sample piece here that has already been cleaned. And that, again, a piece that is stainless steel to mild steel. Now we're going to demonstrate the torch's brazing abilities. It has the ability to braze in 99% of cases without using any flux at all, only when it's heavily corroded material. Here's the torch. We'll start our demonstration by showing it brazing into galvanized material. Now, the torch uses just a standard Tobin bronze filler rod. And have a look at this and notice that we're using no flux, But most importantly, the torch will braze into galvanised material without even burning the galvanising off. Fantastic ability for people such as sheet metal workers, particularly with air conditioning ducting and things like that. The zinc actually will separate under the flame, and it comes back around the edges and really seals in tight on the bronze filler rod. That's lovely, thanks, Lynn. Now you can see there how has really sealed in tightly around the edges. You can actually see the rim of the galvanised material, the zinc, but I'll turn it over and have a look at the fact that it just has not burned any of the galvanised coating off, even off the rear. Now the torch will also braze using the most unusual pieces of gear. Now here it is brazing a piece of spring steel packing strap. This is just old spring steel packing strap. You can notice there it has all the rust and rubbish on it. And what we're going to use for that is just a piece of standard copper wire. And we're going to braze with that. Now, if you tried this with a conventional oxy torch, you would very likely oxidise the copper wire away, and very probably shatter the spring steel. It's the torch's ability to pick up what's around and use it that makes it so amazing. And you'll see it'll run that copper wire around there rather like you would silver solder. The other thing about the torch is its ability to be able to be used on the one flame setting. It's very much easier to use, so you don't have a million fiddly settings to think about. The torch uses what the Americans call just off feather, or a neutral flame, for 99% of its welding operations. I will put this in water and bring it back up again. Just to show you the way that copper is not oxidised in any way there, and how that's done a beautiful braze. And notice again the lack of distortion of the materials too. Now we'll now demonstrate, just on a piece of rusty material, a bit of rusty old exhaust pipe, just to show the torch's ability on more common items that you're likely to find. Now all we'll do here is just blow a hole in it and weld it back up again, just using a piece of ordinary mild steel filler rod. Now you'll see again quite clearly here this very narrow concentrated heat pattern that we were showing before. It's very, very quick, and makes a very, very clean, non-oxidised weld. Just to show something a bit more ordinary that a lot of people pick up rusty old steel and so forth. Again, you can clearly see that very concentrated heat pattern of the torch. It really concentrates on the area you're actually working on and does a very, very clean, a nice, clean, tidy weld. Now, for our next demonstration, we'll be welding some cast aluminium. Now, this is quite unusual to see because notice the aluminium we're using is just a piece of old lawnmower body, and it's quite dirty. You can see here all the old paint on it, and I'll turn it over and show you on the other side. Indeed, you've still got all the lawnmower clippings and dirt on there. Now, the torch is really revolutionary in the fact that it will just weld something like that together without any preparation or cleaning up at all. And the massive advantage of that is if you have a piece of casting that is broken and you can't replace it, for example, because you don't have to clean the edges up with this, you can push the pieces straight back together and relocate all the bolt holes and so forth. Now we're going to be using here just standard 4043 filler rod, and just again a slight bit of flux on the rod. Okay? Now what we'll do, the procedure is to just make the surface just barely move, turn the torch up slightly, and you'll just get the surface to crinkle. Once it's moved, you then turn the torch down to do the actual weld. But unlike a conventional oxy torch, the whole thing doesn't all collapse into pieces on you. Now you see the surface just started to move then, This is just standard 4043, as I said, SIG filler rod. Very inexpensive rod. And again, you notice that technique with the torch 20 degrees off vertical and the rod going under and out of the way of the flame as it goes across. The cone of the flame's held about a 1/16 of an inch above the work. But you, unlike a conventional torch again, you don't have to pull it away, and it does not, as you can see, collapse the material away. It makes it very, very simple to weld even the thinnest cast aluminium. Thanks. Now you can see there that beautiful weld, and if I turn that over, you can see here that lovely penetration through the other side, and that's right through the dirt and everything. Now we'll just drop that in water and cool it so I can show you that cleaned up. And you can see there that beautiful, clean, nice flat repair. And again, as I say, also the penetration the other side. Okay, we're now going to demonstrate some cast iron and the torch's unique ability with cast. Now, it requires no preheating or just a slight warm up of the area. Say, for example, there was a crack in here. Lim will simulate this by blowing a hole in it and welding it back up again. Now, to do this, you would turn the torch up to actually blow the hole, and as you'll see, turn it down again to do the actual repair. Just take the chill off the local area around where you wanted to weld. You'll see again quite clearly it's very narrow, concentrated heat pattern. Quite clearly on the surface of there. And you can see all the rubbish and fumes coming out of that manifold. It's quite dirty. Notice how quickly the torch has got right through that manifold. And now you turn the torch down to do the actual repair. And you can see here, again, it clearly shows that narrow, concentrated heat pattern, which is the whole secret of the torch for all of its welding operations. Just using a bit of standard cast iron filler rod and just some standard cast iron flux. You only really require flux with cast iron when it's dirty like this. Clean cast iron wouldn't require flux at all. If we had enough of it, we could do the entire repair with used piston ring. We run through so much of it that we'll just finish our demonstration with it. Now you can see there that the low velocity of the torch stops the weld puddle from blowing all over the place. Most importantly, doesn't leave a huge bubble of the material inside the manifold. And here we are using a little bit of cast iron piston ring to finish that repair off. Cast iron piston ring is very high grade cast from used piston rings and makes a very, very strong repair. Also fantastic to use for hard surfacing blades. We had one of our customers hard surface his entire plough using piston ring. And the red spots you can see on the top of there are just all the rubbish and lead and so forth coming through that manifold. And you can see the very neat repair that it does. Most importantly, it's not blown a huge amount of that through the other side. So notice that the torch is still quite cool. It's not made the material very hot anywhere near around that area. Now, the preheating is only necessary if you have material, I should say, under tensile stress, such as a wheel or an engine block or something like that. Most cases you can just repair as easy as that. And we're now going to demonstrate cutting. And the torch has two cutting attachments. I'll do that. It has one for panel steel and a cutting attachment for panel steel. Again, it's fantastic for panel beaters. up here. Start out by showing its ability on thin panel steel. My mask. Oh, yeah. Look for my mask. And you can see the cutting attachments going on the torch now. Has fantastic abilities with this because you can literally rest the tip right on the surface and cut a really narrow slot right through it. The torch is still operating at 4 psi on both the oxy and acetylene. And you just set it up as if you would for welding, and your oxy cutting button is used here to take it back to neutral again. So you just simply rest the torch on the material, get it red hot and just cut a narrow slot right the way through it. And you can see there that very, very clean cut on the material. Now the torch will also cut much thicker material. It will cut up to 1 inch thick steel. We have here a piece of bar to demonstrate about 16 mil thick. Very, very quick. If you do a lot of cutting, you save a massive gas on with thicker materials. Now, up until now, we've had the torch at 4 psi on both the oxy and acetylene. This is the only time we ever change the pressure of the torch. We'll put the oxy up to about 20 psi for that bar. Now, a conventional oxy torch would use about 40 psi on that to cut it, and would be very much slower. So your gas savings are quite enormous with this thickness material. And this is the cutting attachment for thicker material. Right, thank you. So I'm just going to go over to the regulators and turn that up to 20 psi. And you can see how quickly that slipped off that piece of steel. And most importantly, how clean the cut is on it. This is the Henrob torch kit. It comes complete with the full instructions and a 2-year guarantee. We also add a list of Australian rods and fluxes to the kit. It also comes with the 4 welding tips that cover the range of the torch from fine jewellery to 1/2 inch mild steel, plus the cutting tip. It has the full adapters to your standard gear, plus the tip cleaners, and what I didn't show in the demonstration, an air acetylene tip for soldering work. Also comes with guide wheels for cutting, which also fit the panel cutting attachment, plus a heat shield for reflected heat. And the torch itself is a very robust piece of gear with only 1 moving part and 1 O-ring in the whole torch, which is in the cutting button, so there's very little to go wrong with it. And it also comes in a very robust carrying case. Now the torch will operate quite easily on any standard regulators, and to obtain the 4 psi the torch uses, this is how easy it is to do it. Now we simply fit the largest tip on the torch, the number 3 tip, open, or close I should say, the regulators fully, open the torch at the handpiece, fully open. So what you're going to do is bypass the torch altogether. Now what we're going to do is introduce the acetylene until we have about a 2 feet feather and we've lost the black smoke, and then bring in the oxy. So you'll see me do this. I won't be able to talk because it's quite loud. And that's all you're looking for, is that 1/2 inch cone. It's as easy as that to set up. Now, the torch then, all operations of the torch are done from the handpiece. Fit your smallest tip after that. This one welds 1/2" mild steel and is very powerful. And just to give yourself a double check, smallest tip on, and set it down low, not that low, and you'll see just how fine it'll actually go. That tip will do fine jewellery work. Now, if you've got it set up correctly, that should be fairly stable. And what you do then is just with that tip running, just mark your regulators, and they're reading 4 psi for all operations.